Good morning, Prep 3. Hello in our second term. In this term, your science curriculum contains 4 units. Unit 1 is talking about the chemical reaction, and this is chemistry. And Unit 2 is talking about the electric current, and this is physics. Unit 3 is talking about the heredity, and this is biology. Unit 4 is talking about the genes and hormones, and this is also biology. Let's start our video today with lesson 1, chemical reaction. To make a chemical reaction, we must have two things. Yes, we must have reactants and products. Reactants and products. And to form the products to complete the chemical reaction, we must breaking down the bond between products and form new bond. The bond between reactants and form the new bond between products. Okay? So what's meant by chemical reaction? It is breaking down of bond between the reactants to form a new bond between products. Okay? This is the definition of chemical reaction. Number 2, the importance of chemical reaction. You took it before in Prep 1. So we can use a chemical reaction in many things, such as making medicine, such as the plants in making photosynthesis process, this is considered as a chemical reaction, and in making fertilizers, and so on, like burning the fuel in the car. Okay, so this is the importance of chemical reaction. The importance of chemical reaction: number 1, the burning of car fuel; number 2, photosynthesis process; number 3, in making medicine, fertilizers, and artificial fiber. Okay. And now let's go to see the types of chemical reaction. In this year, you have 3 types of chemical reaction. Number 1, thermal decomposition reaction, and number 2, substitution reaction, number 3, oxidation and reduction reaction. In this video, we will talk about the first type only, which is thermal decomposition reaction. Pay attention, when I said thermal in chemistry, this means that here I have a heat energy. So this is thermal. And decomposition means divided or decompose the compound into 2 elements or more, into its elements. So this is what's meant by thermal decomposition. If I ask you about the definition of thermal decomposition, you will say it is a chemical reaction breaking down of bond between the reactants by the effect of heat. And you must here say the effect of heat, as it is thermal by the effect of heat, to decompose the compound into its element. To decompose the compound into its element. Let's go to see the definition. Its definition: it is the reaction which involves the breaking up of the compounds, or the bond between the compounds, with the effect of heat into its sample elements. Okay, and this is the general equation of thermal decomposition. Here I have AB. This is a compound, consists of 2 different elements. You know that the compounds consist of 2 or more different elements, and by the effect of heat it decomposes into its elements, which are A plus B. Let's go to see different examples of thermal decomposition. Number 1, thermal decomposition of red mercuric oxide. Pay attention. Mercuric oxide, its chemical formula is HgO. This is mercuric oxide, and its color is red. So by the effect of heat, it decomposes into 2 elements, into its elements, which are mercury Hg, that is have a silver color, and oxygen, which is gas. So I put an arrow beside oxygen, indicate that this is a gas, evolving gas. Okay, so the chemical equation of a thermal decomposition of red mercuric oxide must be written like this equation. HgO, this is mercuric oxide, by the effect of heat, the triangle related to the effect of heat, producing two elements which are silver and which are mercury and oxygen. Pay attention, mercuric oxide has a red color, but mercury only has a silver color. Okay? Okay. Can you see the coefficient beside the compounds and elements? Yes, I write here 2HgO. What's meant by 2HgO? Producing 2Hg plus O2. What's meant by these coefficients? These numbers must be written to balance the chemical equation. How can I balance the chemical equation? I can balance the chemical equation by the number of elements in the reactants must be equal to the number of elements in the product. Like this. In the reactants we have 2HgO. This means that I have 2Hg and 2O. And in the products I have 2Hg plus O2, which means 2O. Okay? Let's go to see the second example of thermal decomposition. Thermal decomposition of blue copper hydroxide. The chemical formula of copper hydroxide is CuOH by 2. Pay attention. Here I put OH between two brackets and write 2. 2 is the valency of copper. And OH is atomic group that is called hydroxide. So when the atomic group take a valency, I must put the atomic group between two brackets. This means that I have 2 oxygen and 2 hydrogen here. Okay? The thermal decomposition of blue copper hydroxide. Copper hydroxide, its chemical formula CuOH by 2. Its color is blue. By the effect of heat, it decomposes into its elements, which are copper oxide that has a black color, and producing H2O evolves, and this means that this is water vapor, not liquid. Okay, let's see third one. The thermal decomposition of green copper carbonate. Green copper carbonate. The chemical formula of copper is Cu, and carbonate is an atomic group. Its chemical formula is CO3. Okay, so the copper carbonate, its chemical formula CuCO3. It has a green color. It has a green color. By the effect of heat, it decomposes into its elements, which are CuO, and this is copper oxide that has a black color, as we said, plus carbon dioxide that is gas and must evolve. This is 3 examples. Let's go to see the fourth one. Number 4, thermal decomposition of blue copper sulfate. Yes, we know that the chemical formula of copper is Cu, and the chemical formula of sulfate is SO4, and this is atomic group. This is called blue copper sulfate, CuSO4. By thermal decomposition of blue copper sulfate producing its element, it decomposes into its elements, which are CuO, that is copper oxide that has a black color, and producing SO3 sulfur trioxide, which is evolving gas. Number 5, the thermal decomposition of white sodium nitrate. White sodium nitrate. The chemical formula of sodium is Na, and the chemical formula of nitrate is NO3. You must know that. Okay. NaNO3, sodium nitrate, which is white powder. By the effect of heat on it, it decomposes into its elements, which are sodium nitrite. Pay attention, nitrate NO3, nitrite NO2. Okay, decomposes into its elements, which are sodium nitrite, yellowish white, its color is yellowish white, plus O2 evolves, which is oxygen gas. Pay attention here in this chemical equation, we have a coefficient 2 beside the sodium nitrate and 2 beside sodium nitrite, and this is balanced to balance the equation. Okay. Here we have finished the thermal decomposition, and we have 5 examples of thermal decomposition. Please listen carefully to the video and study harder, and goodbye.
This is a demonstration of the decomposition of copper 2 carbonate. It's decomposing, or will decompose, into copper 2 oxide and carbon dioxide gas. We're going to take a test tube with about a scoop full of copper 2 carbonate. We're going to heat it evenly over a blue flame, holding the test tube away from yourself and away from others. And as it heats up, it will begin to bubble, and you'll see the powder bubbling a little bit. And we're going to test for the presence of carbon dioxide by taking a splint, light the splint in the flame, hold the lit splint over the mouth of the test tube, and if this lit splint goes out, that will indicate to us that indeed carbon dioxide is being released during this reaction. Again, this is an example of decomposition of copper 2 carbonate, and it's going to form copper 2 oxide and carbon dioxide. Heat the copper 2 carbonate in the flame until you start seeing some movement in the powder. And again, just remember to point the test tube away from yourself, away from others. And it takes just a minute for it to heat up. And again, this is a decomposition reaction. So we're taking a larger molecule and breaking it up into smaller molecules. So as the copper 2 carbonate is decomposing, carbon dioxide gas will be given off, and then we're going to test for the carbon dioxide gas by taking the lit wooden splint, holding it into the mouth of the test tube, and if it goes out, the wooden splint goes out, we'll know that there is indeed carbon dioxide being released. That's also a way to test for the presence of carbon dioxide. All right, it's starting to bubble a little bit. Give it just a little bit more time. Light your splint. And indeed it does go out. And I'm not sure if you noticed, but the flame actually turned a little green, and that's because some copper actually got on the wooden splint, and the copper will burn green. So if that happens, that's normal. And we'll see if any more carbon dioxide is being released. So it's still reacting. And that is an example of decomposition.